Let's take a look at this marker. If I tilt it right now and I put it right here, and then I exert a force on top here, like this. When I exert a force on top right here, there's going to be something created here as a result of the force. There are graduations of this marker being created right there as a result of the force. Likewise, if I put this on my skin like that, you will see, if you look closely, that there is some marking that has been created there as a result of the force that I've exerted on this marker. If I do the same, this is my pen. This is the nib of the pen. If I do the same and I pinch my skin, ouch, right, like that, you realize that if you look closely to my skin, there is a depression that I've created as a result of this nib pinching into my skin. I exerted the force on the marker, I exerted the force on the pen, and as a result of exerting that force, a certain pressure was created. Now that pressure is what led to those things being created, the depressions on my skin. In this video, we are going to look at pressure. What is pressure? Pressure is simply that force that is acting normally per unit area. Now, when I talk about a force acting normally, I am talking about a force that is acting perpendicularly. That is what I mean by normally. It is normal. The force is supposed to be normal to the surface. If this is the force and this is the surface, they are meeting at 90 degrees. If that is the surface, that is the force, they are meeting at 90 degrees. So the force that is acting normally per unit area is what we are calling pressure. And the formula for pressure, in general terms, pressure is going to be equal to force over area. Now, the standard SI unit for pressure is newtons per meter squared. It comes from force. The SI unit for force is newtons. The SI unit for area is meters squared. So it is newtons per meter squared. And 1 newton per meter squared is given as pascals. So we are going to look at pressure in solids. And one of the things about pressure in solids is that it's going to depend on its surface area. Remember, we are exerting a force, and we are exerting this force over a certain area. Let's look at an example. A force of 10 newtons is exerted on an object of an area 5 meters squared. Calculate the pressure exerted over that area. We are going to do it like we've been doing in the previous question. In our previous question, we had a similar question. We had a box, it had a face, the face had a certain area that we had to first calculate. Likewise here, we've been given the area of the face, which is 5 meters squared direct, and the force. So to calculate the pressure, we get pressure is going to be equal to force over area. That's the formula. So according to our question, force is 10 newtons. So it's going to be 10 newtons, divide that by the area. The area we're talking about here is 5 meters squared. So definitely our answer here is going to be 2 newtons per meter squared as our pressure, which can also be 2 pascals. Our force is in newtons, our area is in meters squared, so it is 2 newtons per meter squared. Now, should you be given a question where instead of giving you the force directly, you've been given mass, it means you're supposed to first find the force. And we know that force is equal to mass times acceleration. Should you be given a question where the area is given in other units other than meters squared, you have to convert them to meters squared, because the SI unit for pressure is newtons per meter squared. So you need to make the necessary conversions so that your answer is in newtons per meter squared or pascals. Right here they're telling us that the size of a box resting on a table has one of its faces whose dimensions are 4 centimeters by 5 centimeters in contact with the table. Find the pressure that the box exerts on the table if the mass of the box is 8 kilograms. Now the box they're talking about could be something like this. A box like this. They're telling us that one of its faces, let's assume this is one of the faces of the box, it is in contact with a table like this. This face is in contact with this table like that. And they're telling us that the box this box, when it is lying on this table, definitely it's going to exert some pressure. Why is it exerting some pressure? Because this box is having some weight, and that weight or that force is exerting a certain pressure on the table. So what is the pressure that is being exerted? If this box is having a mass of 8 kilograms. So in our sketch, we do have, that's the box, and it is seated on a table, like that one. Now, according to our question, the dimensions of the face of the box that is in contact with the table is 4 centimeters by 5 centimeters. It means that the dimensions here are, this is 4 centimeters and these are 5 centimeters. So now, if this is 4 centimeters and 5 centimeters, the weight of this box, according to our question, is, this thing is 8 kilograms. So meaning it is 8 kilograms. So from our formula of pressure, we know that pressure is going to be equal to force over area. Now we do not have the force, but we have the mass of the box. The mass of the box is 8 kilograms. So we can find the force or the weight, because force and weight is the same. So the force or the weight of this box is simply going to be equal to mass times gravity. And our gravity is 10. So we get the force or the weight of that box. Then now for the in newtons, definitely. Then for the area, we realize that our area here of the face that is in contact with the table is going to be this times that, which is 4 times 5. But this is in centimeters. So it means the area we shall be getting will be in centimeters squared. But remember, we already explored and said that as far as pressure is concerned, the SI unit is newtons per meter squared. So it means that our force here is supposed to be in newtons and our area here is supposed to be in meters squared, but the figures they've given us are in centimeters. So what we do, we have to first convert these to meters, so that the area we get here is in meters squared, so that the answer we eventually get is consistent with the SI units of pressure, which is newtons per meter squared. So we shall begin by getting the force. First, our force is going to be mass times gravity, and the mass is 8 kilograms, so it's 8 times gravity, which is 10, and that is going to give us 80 newtons. Then after getting our force, we shall go ahead and get the area of this face. Now the face is 4 centimeters by 5 centimeters. But then we need to convert this first to meters. So 4 centimeters, converting that to meters means it's going to be 4 centimeters divided by 100, and we shall end up with 0.04 meters. And here 5 centimeters, converting that to 100, we'll end up with 0.05 meters. So it means that the area is going to be, we are going to now use the length that are in meters. So it's going to be 0.04 meters, multiply that by 0.05 meters. And what we get there is going to be, so now after getting our force in newtons and getting our area in meters squared, then we can go ahead and say that our pressure therefore is going to be equal to force over area. Our force is 80 newtons, divide that by our area, which is 2 times 10 to the power negative 3 meters squared, and our answer is going to be 40,000 newtons per meters squared, or call it 40,000 pascals. Let's take a look at this box right here. It is resting on a table. Now this box has got several faces. It has got 6 faces, but we are going to concentrate, or we are going to concern ourselves with 3 of the faces. We have face A, we have face B, and we have face C right there. Now, if you look at face A, the surface area of face A is slightly bigger than the surface area of face B, and then the surface area of face C is the smallest. Now each of these faces can get into contact with the table. For example, face A, if I want it to be in contact with the table, I simply put it in contact. Face C, if I want it to be in contact with the table, I'll simply do that, and so forth. And so with face B. Now when these 3 faces are in contact with this table, because this thing has a weight, it's going to exert pressure on this table. But remember, we said that in our previous video that pressure is going to be equivalent to force over area. So it means if the pressure is going to be equivalent to force over area, it means that the amount of pressure that is going to be exerted by all these faces when they come into contact with this table is going to be different, because the surface areas are different. The area here is bigger than the area here. So it means when those three get into contact with this table, don't expect the pressure to be the same. But the weight of this thing will still be the same. But because the surface areas that are in contact with this table are different, that is going to make the pressure exerted onto this table to be different. In this video, we are going to explore, or we are going to investigate how the surface area of contact affects the pressure in solids. This is Kisembo Academy, and thanks for tuning in. We are going to investigate this using a worked example. We have a question. In our question, they're telling us that the weight of this cuboid is 60 newtons. Find the pressure exerted by the faces A, B, and C. So you're going to find the pressure exerted by face A, face B, and face C. Then we shall compare the pressures exerted and come to a conclusion. Okay, so we begin our calculation with finding the pressure on face A. If face A gets into contact with the table, what is the pressure that it will exert? So pressure is going to give us force over area. Now for face A, the force, which is the same as the weight, is 60 newtons. So it's going to be 60 newtons. Divide that by the surface area. Now the surface area of face A has dimensions of 0.2 times 0.1. So the surface area here is going to be 0.2 times 0.1. This is meters squared. And the answer is going to be, it's going to be 60 newtons. Divide that by 0.02. And definitely our answer here will be 3000 newtons per meter squared. That is the pressure of A. Let's go on to pressure of face B. The pressure of face B is going to be equal to force over area, and that is going to be equal to the force, which is still the same, which is 60 newtons, which is the weight. Divide that by the area. Now the dimensions of area of B, the area of this face is 0.2 times 0.05. So this is going to become 60, divide that by 0.2 times 0.05 gives us 0.01. This is newtons, this is meters squared, and we end up with our answer being 6000 newtons per meter squared. Then we have face C. Now the pressure for face C, pressure on face is going to be equal to force over area. We know that our force is still going to be the same. The thing is 60 newtons. So it's 60 newtons, divide that by the surface area. Now if you look at the dimensions of C, it is 0.1 times 0.05. And 0.1 times 0.05, this is supposed to be meters squared. So it's going to give us 60, divide that by 0.1 times 0.05 is going to give us 0.005. And we shall get the pressure there being 12,000 newtons. Newtons per meter squared. This is the pressure of A. This is the pressure of B. And this is the pressure of face experienced on face C. Now, you realize that we are still having the same box or the same cuboid. It is having the same weight, which is 60 newtons. But when you make this thing lie on the surface of the table, on these three different faces of A, B, and C, you realize that the pressures being exerted are different. Now let's try and compare these pressures that are being exerted on this table. We try and relate them with the area. If you look at the area of A, the area of face A, remember we got it as 0.02. The surface area of box B, we got it as 0.01. And the surface area of C, the area of the face is 0.005. If you look at the surface areas, you realize that surface area of A is the biggest and the surface area of C is the smallest. But then when you look at the pressure, you find that the biggest pressure was experienced on surface of C, and the smallest pressure was experienced when surface A was in contact with the table. So what conclusion does this bring us to? This brings us to the conclusion that the smaller the surface area of contact between the box and the table, the bigger the pressure will be. And the bigger the surface area of contact, then the smaller the pressure will be. So this brings us to the conclusion that pressure in solid is dependent on area in such a way that the smaller the area, the higher the pressure. As simple as that. This explains why when I get a needle and I prick myself, I will feel more pain if I use the sharp end than when I use the blunt end. Let's use this pen. It has got the sharp end and the blunt end. If I got this sharp end and I pricked myself, ouch, I'll feel more pain. But if I use this blunt end and I try and prick myself, I can even do this, but I can't afford to do that on this side because it's sharp. I'll feel more pain. This is because the surface area of contact here, between the surface area of contact between this pen and my skin is small. So because the surface area is small, I will experience a higher pressure, and that higher pressure will bring about more pain. Yet this way, the surface area of contact between this and here, it is big. So the bigger the surface area of contact, the lower the pressure, and so that's why I feel less pain. It is the same explanation with tractors. If you've been to Africa and you know that some roads are muddy, some roads are impassable, or even in a garden. But you find that if a small car is to come and pass by in a very muddy area or in a slippery zone, it will get stuck in the mud so easily. But then if a tractor came around and it will just hover over the mud and drive through very smoothly. Now, why is that? Why is it that a tractor, which is very heavy, can easily hover over a muddy place, but then a small car whose weight is less will get into the in the mud and get stuck? The principle is just this. If you look at the tires of a car, they are very small. And so because they are very small, when they get into the mud, they exert a very high pressure. And when they exert the very high pressure, they get into the mud and they get stuck there. So the high pressure that this the small surface area of these tires is exerting onto the mud gets the car stuck. But if you look at this tractor, however big it is, but because it is having a very wide surface area beneath its tires, because it means that those tires are going to exert a reasonably low pressure onto the mud, and as a result, because of this low pressure that is being exerted onto the mud, the tractor will easily hover over the mud. We can try that question right in front of our screen. The head of a nail has an area of 0.5 centimeters squared. Find the pressure exerted on its head when the weight of 5 newtons act on it. So pressure is going to be equal to force over area. So if this nail is being acted on by a weight of 5 newtons, so it means that the force is going to be equal to 5 newtons. Divide that by the area. Now, the area of it's 0.5 centimeters squared. So our answer we have to first convert this area into meters squared, so that we have the right SI units acting right there. So it means that to convert 0.5 centimeters squared to meters squared, we are going to divide 0.5 centimeters squared. We are going to divide that by 10,000, and we shall get 5 times 10 to the power negative 5. So it means that here it's going to be 5, divide that by. So the area exerted there is going to be 100,000 newtons per meter squared. Please remember that when we are given numbers like this, we are supposed to first make sure, before we get the answer, that the force is in newtons and the area is in meters squared. If they are given to us in any other units, we have to endeavor to first convert them back to the SI units of those respective quantities before we do the divisions. A glass block of density 25,000 kilograms measures that. What is the maximum pressure it exerts on a flat horizontal surface in newtons per meter squared? Let's draw a sketch for this. The block in question. A glass block of density that measures 20 centimeters by 10 centimeters by 5. So if this is our block, the glass block, it is having 20 centimeters right there by 10 by 5 centimeters. They're asking us to find the maximum pressure exerted on the flat or on a flat hole. The maximum pressure it exerts on a flat horizontal surface in Newton per meter squared. So it means if they want the question in Newton per meter squared, it means even we are supposed to first make sure that this is the SI unit. So it means our force is supposed to be newtons and our area is supposed to be meters squared. We know that for us to be able to find the pressure, it is going to be equal to force over area. That is pressure in solids. Now what is our force? Now we do not have the force, it's not directly given to us in the question, so we need to first figure out what force we are going to use here. So to find the force first, we know that force is going to be mass times gravity. What is our mass? The mass is not given according to the question. In our question we only have density, and the density they've given us is 2,500 kilograms per meters cubed. So we use that density to get the mass. So this is going to transition into this. That force is going to be equal to we know that mass is density times volume. Times our gravity, which is 10. Now, we have the density in the question, we can get the volume because we have the dimensions of this, so we can get the volume. Now, we can get the volume by the volume of this cuboid is going to be length times width times height. But now, since we are calculating for pressure, we try and first convert these to meters. Then we work when our figures are already in meters. We make our conversions from here. So it means that right here, our 20 centimeters, when we convert this to meters, it's going to become 0.2 meters. Our 10 centimeters to meters is going to become 0.1 meters. Then 5 centimeters to meters is going to become 0.05 meters. Now that simply means that our volume here is going to be our next step here is going to be density. Now, according to our question, the density is 2,500 kilograms per meter cubed. So it's going to be 2,500. Multiply that by the volume. Now the volume is length times width times height. The length here is 0.2 times the width, which is 0.1, times the height, which is 0.05. Now multiply that by the gravity. Now the gravity will become is 10. It's a constant 10. So when we compute all this, we shall end up with 25 newtons. So it means that the force we have got is 25 newtons, the force. So after getting the force, now we go ahead and find the area. Now remember, they're telling us to find the maximum pressure. And according to our previous video, we said that according to pressure in solids, the smaller the area, the higher the pressure. So if they want the maximum pressure, it means this maximum pressure is being exerted onto the smallest surface area. Oh no, it's being, or if you look at these three faces, they are looking for the maximum pressure. So it means that the maximum pressure is achieved when the smallest area of these faces is the one being in contact with a surface. So it means our task, for us to be able to find the maximum pressure, it means we are supposed to find the smallest area of this. So let's compute the areas. Let's call this A, B, C. If you look at the areas of A, the area of A is length times width. The length is 0.2. Multiply that by the width, which is 0.05. And the area of A is definitely going to give us 0.01 meters squared. So the area of face B, which is that one, face B is going to be length, which is 0.1, times that, which is 0.05. And definitely right here we are going to end up with 0.005. Then C, this face C, is going to be length, which is 0.2. Multiply that by the width of this, which is going to be 0.1. Now 0.2 times 0.1 is 0.02. This is meters squared and that is meters squared. Now if you look at all these three faces, A, B and C, you realize that the smallest area is B. B is having the smallest area of 0.005 meters squared. Now if this is the smallest area, it means that here is where the maximum pressure is going to be experienced. So for us to calculate for maximum pressure, P maximum is going to be equal to the force over smallest area. So the force, we got 25 newtons. Divide that by our smallest area, which is going to be 0.05 meters squared, and our answer will be, that is going to be our maximum pressure exerted. Now the maximum pressure is exerted on the smallest area, and in that we have answered the question. The question is requiring us to find the maximum pressure. Now if they required us to find the minimum pressure exerted by these faces, it would mean that we are supposed to look out for the biggest area. So it means for pressure, when to find the minimum pressure exerted by this cuboid, if one of its faces is to go into contact with the table or with the surface, it would still be the same force exerted by that, divided that by the biggest area. And definitely the least pressure, if you had to calculate, would be 1250. This brings us to the end of this video. Thanks for watching. For more of these videos, simply subscribe. And please remember to share this video. For Kisembo Academy, this is Arnold Rwangakurame.